Pick it up, notch. Gotta learn something new with moles. Yeah, I'm back on my singing random songs shtick. Let's talk about two-step mole conversions. We already did one step. That was the last video. Let's talk about two-step. So we are going to start with our mole map, which is this idea that we can convert between grams and moles and particles. And right now, when we talk about particles, we're mostly talking about atoms, but one day we'll also talk about molecules. The relationship between these things allows us to make conversion factor fractions that compare grams and moles, or compare moles and grams, or compare moles and atoms, or compare atoms and moles. Notice that at no point is there a fraction that compares grams and atoms directly. That's not allowed. You can't do that. And that brings us back around to this color coding idea we've been doing, where we were using green for moles because you have to have moles in the middle or green in between. We were using yellow for grams, gold and grams. Atoms are blue because when it's blue, your number in your conversion factor is 6.02 times 10 to the 23rd. When it's blue, use 6.02. Your number of moles in your conversion factor will always be 1. So like looking at the possible conversion factors we can have, there's 4 different conversion factors we can have, and in all of them, wherever the word moles is, you need a 1 next to it. Similarly, there's 2 conversion factors that you could use with atoms, and for both of those, atoms are blue. When it's blue, use 6.02. When it's blue, use 6.02. It rhymes. Times 10 to the 23rd. This is Avogadro's number. And that leaves us with figuring out what number goes with our golden grams. Well, when you're making a conversion factor with your golden grams, the number needs to be a number of grams from the periodic table for whatever element the problem's about. Again, the reason we use this color coding is to help us remember that grams can go with moles and atoms can go with moles, but atoms and grams can never go together. Just like if you ever tried to combine yellow and blue, it wouldn't work, because anywhere you try to stick yellow and blue together, you get green. Yellow and blue can never be together. They're always going to have green in between or moles in the middle. So the color coding is to help us remember what types of conversion factors are allowed and which ones are not allowed. So with that in mind, let's try a problem that uses more steps. If we look at this example problem right here, in chemistry class, the student was using 189.2 grams of sodium. Notice where they give you a number, that's your given, and it asks how many atoms were used up. So you've got this question word how here, telling you how many atoms is what it's asking about. So atoms are going to be your unknown there. And you can color code these too. That's actually our step 0, is to go ahead and color code the problem itself. And you'll notice this is different than the other problems we did. The problems we did in the previous video had yellow and green together, or they had blue and green together. We didn't have yellow and blue together in any of those problems, but now we do. Which brings us back to what these steps we did were talking about, where we're going to do step 1, write your given, whoops, I forgot to write your given number, unit, and element over 1. We're still going to do that even though this is a little bit of a different problem because we've got grams and atoms together, we're still going to write that given 189.2 grams of sodium. Write your given down always. That's always where you start. Always start with the given. Why would they give you a number if they didn't want you to use it? Always, 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 always start with your given. We're going to do all kinds of weird math all year, but it will never change that your first step should be to start with your given. Every single time, start with your given. And if it makes you more comfortable knowing you're going to be multiplying fractions, you can draw that as a fraction over 1. You don't technically need the over 1. It's just whatever makes you more comfortable when we start doing the actual math. Your next step is to decide how many fractions and then draw them. We said that if you see the word moles, that tells you it's a one-step problem and you need 2 fractions. If you do not see the word moles, which in this problem we did not see the word moles, then that means we're going to need 3 fractions, as you may have guessed. So let me erase this little color diagram. That's going to be your given, which again, if you want to write it over 1, you can, to help you count out your 3 fractions, but it's going to be times another fraction times another fraction. So you could say this is 2 fractions or 1 step, and you could say this is 3 fractions or 2 steps. It's just whatever makes you more comfortable to think about it. Going down. Okay. So we do not see the word moles here. That means I need a 2-step problem or a 3 fraction problem if your given is being written as a fraction over 1. Let's think about our color coding. This is grams, and your next step is going to stay the same, where you take your unknown and you write it on top at the end. So our unknown here is atoms of sodium specifically. On the periodic table, sodium is Na. So that is my unknown, and your unknown always goes on top at the end. Our next step is what goes up must come down, which is where we think about our conversions. If I want to get rid of grams so that I can eventually turn it into atoms, so instead of grams, I eventually want atoms, then to do that, I'm going to need to simplify out the grams. So what goes up must come down. We're talking only about the units here, not about the numbers. Whatever units are on top, you move them down that diagonal. Because when you move them down that diagonal, that allows you to simplify out the units. Now here is where things get a little different and interesting, and you need to think about this mole map, because we know that we cannot go from grams straight to atoms. That's not allowed. You're not allowed to do that. Okay, you can't. We don't have a conversion factor that lets me put grams and atoms together. But I do have a conversion factor that lets me put grams and moles together. And I have a different conversion factor that lets me put moles and atoms together. So we're actually going to daisy chain these together to get to where we want to go. And this is, again, coming back to moles in the middle as one of our little memory tricks. Moles in the middle, green in between. Where, oops, it says between. That's not supposed to be there. Don't look at that. It's nothing. It's just, nope. Okay, technical difficulties. Yeah, moles in the middle, green in between. So we look and we see that, like, we've got yellow and blue, which can never go together. Anytime you try to put yellow together with blue, you end up with green in between, which means there need to be moles here. Yellow and blue can never go together. You need green in between, moles in the middle. And then for this final empty spot, this comes back again to this idea of simplifying. I know moles are not supposed to be my final answer. I'm going to have to get rid of those by simplifying them out. So if I have moles on top and I can also get moles on bottom, then having the same thing on top and on bottom will make those simplify. And that'll leave me with, here's grams twice, moles twice, they've simplified out. I'm left with just atoms on top, and conveniently, atoms is what I want. So that's gonna end up being the label for my answer. And there, now I've used atoms twice too. You use every unit in the problem twice. Okay, we still have to fill in numbers. So let's look at it. We know that our number of moles should always be 1. Oops, I forgot I was using highlighter still. Our number of moles should always be 1. So I'm going to stick a 1 in front of the number, in front of the word moles every time. Stick a 1 in there. For atoms, when it's blue, you use 6.02 times 10 to the 23rd. And your grams have to come from the periodic table. So you got to find sodium on the periodic table. It's right there. Sodium is has a mass of 22.99. And there you go. There are a lot of different ways you could potentially put this in a calculator. We've talked about multiplying fractions before in several other videos. So I'm not gonna like super bore you with that. I personally, if I don't have a graphing calculator handy, I go ahead and use Google Sheets. The most important thing to remember is that when you put the scientific notation in your calculator, you want to make sure you use that capital E for exponent in the calculator to make sure that you don't have to worry about parentheses. And to get that E, if you're using a graphing calculator, to get the E, you press second and then the comma button to get that E. If you're using Google Sheets, you literally just type a capital E. But anyway, if you've calculated this correctly, your final answer should be 4.97 times 10 to the 24th. And I want to do another one with you also. So let's scroll down to yeah, this bottom one, 87.5. You know what? I think I typed something on that previous problem. Yeah, I did. It should be 4.95 times 10 to the 24th. Sorry about that. My bad. Okay. Now we'll look at that bottom problem. If someone needed 87.5 grams of carbon, how many atoms of carbon will be used? Again, just start with the color coding. Thinking about what colors and therefore what units you have available is going to be helpful. Again, if you don't have colors at home, that's fine. Instead of thinking about colors, just think about units. I see grams and atoms together, which tells me something if I am thinking about it. Either way, wherever they've given me a number, that given needs to be the first thing that I write. You can write it over 1 if you want to, if that makes you more comfortable when you multiply fractions. You don't have to write it over 1. You could just leave it like this, whatever is more comfortable for you. But then when we think about how many fractions do we need or how many steps do we need, I do not see the word moles. So this is either a 3-fraction problem, or if you're not writing this as a fraction, you can think of it as a 2-step problem. But you know, pick your preference. Then we need to think about where our unknown goes. So you're asking how many atoms of carbon. There's your question word right there telling you, hey, this is the unknown they're asking us for. Unknown always goes on top at the end, wherever that is on top at the end. So we put it in there. Our next step is about simplifying. What goes up must come down. So I want to simplify the carbon grams by, if I have them on top, remember, even if you're not writing this as a fraction, that's still technically on top. So it'll simplify with something on bottom. And then to figure out what goes in this empty spot right here, remember, grams and atoms can never go together. Yellow and blue can never go together. If you try to mix yellow and blue, you get green in between, moles in the middle. So again, even if you don't have colors to color code with, grams and atoms can never go together. You have to have moles in the middle or green in between. Your number of moles is always, whoops. There you go. Your number of moles is always 1. And we can again figure out what goes here by thinking about what goes up must come down, that we need to simplify whatever units are on top by bringing those same units down to the bottom. When we have the same thing on top and bottom, that allows us to simplify. And again, I know that the word moles should always go with a 1. Atoms are blue. When it's blue, we use 6.02 times 10 to the 23rd. Our number of grams comes from the periodic table. If you check carbon on the periodic table, look at it, I'm moving it backwards, aren't I? There. 12.01 is your number of grams for carbon. And when you multiply all of that out, if you're putting it in any kind of calculator correctly, you should get 4.39 times 10 to the 24th. And since the only unsimplified unit here is atoms of carbon, that's what we're going to label the answer with. Boom. Okay, so I actually skipped a problem on this page that goes the opposite direction of the two I just did with you. Like you'll notice that this time in this problem, if you're thinking about your colors or thinking about your units, this time the given is atoms and the unknown is grams, so they've swapped it. I want you to pause this video and try that yourself. And then when you press play, I will run through that problem. Pause the video, try it yourself. Did you do it? Did you try it yourself? I hope so. Just see how far you can get. See how many steps you can do without watching me. Like, I bet if you had bothered to try yourself, you would have been able to just write the given and over 1 if you prefer, right? Without any trouble. That's not a hard step, just rewriting it. You could figure out how many steps / how many fractions. Right, we do not see the word moles here, so that's going to be 3 fractions, or you could say 2 steps if you're not writing the given like a fraction. Whichever way you want to think about it is fine. The unknown goes on top at the end. And our next step is what goes up must come down. Ideally, by the end of this video, everyone should be able to get at least this far by themselves before they have to go back and rewatch anything, ideally. Once you can get to this point, if you get stuck, that's okay. That's the nice thing about videos is you can go back and rewatch it. But hopefully you can at least get this far at this point or by the time this video ends. Then if you get stuck, here's what we think about. We managed to cancel out or simplify the atoms on top and on bottom. We need to convert to grams, and I know that atoms cannot go directly to grams. That's not allowed. I have to pass through moles first. So if I have to pass through moles first, that means, oh yeah, moles in the middle or green in between. So I'm going to put those moles in the middle. And then if I want to know what goes in this spot, I think about what goes up must come down. If I want to simplify out these moles, because that's not the answer I need, the question's asking for grams. It's not asking for atoms. It's not asking for moles. The question wants my answer to be grams. So how do I get rid of those moles? I'm going to have to simplify them by making sure the same thing is on top and on bottom, so it divides out, like we talked about in that fractions video. So from there, if you can get all your words in the right place, filling in the numbers should be easy because your number of moles is always 1. And your number of atoms, when it's blue, you use 6.02 times 10 to the 23rd. It mostly rhymes. When it's blue, use 6.02. Your number of grams comes from the periodic table. If you check calcium, it's 40.08. Believe? Yeah. I know what I'm doing. Okay, there you go. Calcium 40.08. And again, sticking this in the calculator, I'll go ahead and screen share my calculator this time. Hold on a second. Let me find a clear space here. So we want 7.29 times 10 to the 23rd. That's over 1. You don't really have to type it over 1 if you don't want to. Then the next fraction is 1 over 6.02 E23. And the next fraction is 40.08 over 1. Now, if you really want to, you can type all of this as fractions, where you do like this divided by that. And then that fraction is times this divided by that. And then that fraction is times, a fraction's a division problem, right? So this divided by that. You can do that. You can type it that way. That's totally fine. I will say that's the slowest way to type it because if you're thinking about it, multiplying by 1 and dividing by 1 doesn't change anything. So you could type it instead as just recognizing like this is on top. It's going to get multiplied by this other thing that's on top. And then this thing that's on bottom is going to get divided. You get the same answer, 4.85 E1, which is the same as if you're not using a Google Sheets. Then your calculator would probably give you 48.5 for that, but that's the same thing. So anyway, there you go. That's a 2-step mole problem. There are practice problems for you. Good luck. I am sure you're gonna do really great.